Hello, welcome to our third video of Naughty Mojo Jojo lectures. I always find it difficult to pronounce it. I still don't know how many J's are there in Mojo Jojo. Anyway, let's get to our topic. An equation for pressure. An equation for pressure. Now first, for that I'll have to draw a figure. Yes, like always it's a cylinder. Stupid cylinder. This is quite a symbol. Oops, sorry for that. Cylinder, and imagine that I have something over here in that cylinder, some piece of block. I'll color it with a different color, brown. Okay, so you get the idea, right? Okay, so let's say that this is area 1 and this is also area 1. Let's say it's a, the both sides of the cylinder are equal, or I think it won't be called a cylinder, it will be called a frustum. Okay, now we have some liquid filled till here of this container, so don't think that this actually blocks the passage. We also have that liquid over here. Let me color that. Okay, same liquid over here. Yes, so just assume that the mass of this liquid above this thing is m. Consider this mass as m, the mass of this liquid above this piece of material. Let's assume that it's wood. Okay, just so that we can call it wood every time, and assume that the force exerted by this liquid over here on this piece of wood is Fd. Fd, force is equal to mass into gravitational constant, m into g, that is Fd. Okay, and we experience a force Fu above this, from below. That is the buoyant force about which you will learn in future videos, but if you don't actually want that now. And also consider this height h, height till here. Okay, till here, that is h. Okay, now let me write something. What is Fd? Fd, what is this Fd over here? As you know, according to Newton's law, force is equal to ma, right? Mass and acceleration. Now here, in our case, what is m? We have simply put it as m itself. And what is a? It is a gravitational constant, right? Now I'm gonna make a change in this equation. You know that volume is equal to mass by density, right? Volume is equal to mass by density. Put that in a box. Volume is equal to mass by density. So I can also write this equation as we can write it as volume into density. Volume into density. Let me write that again. It's not right. Oops, sorry. Volume into density into g, or the gravitational constant. This is raw. So I can also write FD as Now what is this volume over here? What is volume? Volume is base area into height, right? So what is the base area over here? The base area is A1, right? And the height is h. So volume is equal to base area into height. Therefore A1 into height into rho into the gravitational constant. So we also get an equation for force over here, which can be used for finding the force. This equation can be, oops, wrong tool. This equation can be used to find the force. Now from here, so what is pressure? As you know, pressure is force by area, right? Pressure is force by area. Therefore FD by area 1, right? That's the area of this. That's the force this wood piece is going to experience. Therefore we write it as A1 into H into rho into G divided by A1, right? So these two cancels off. We get pressure equal to H rho G. Now that is the equation for pressure. That is an equation which we use most of the time to find the pressure. Okay, now I'll make you more familiar with that equation by doing a problem. Let me clear this off. Let's pop all over there. Okay, so consider a container. Now assume that the container is open. Container is open, and we have a piece of wood. Same wood, or the same wood, yeah, maybe same wood over here, and we have a liquid. Let it be water. You have a liquid filled till here, right? Color. Okay, we have a liquid over there. Now we are going to find the pressure exerted on this piece of wood. For that we need the height, right? Let this be H. Let it be 10. We'll consider it 10 meters, not centimeters. It's not SI unit. Let it be meters. 10 meters. That is the height of the water above this wood. Yes, H is equal to 10. Now we need to find the pressure. Okay, that's the question. That's all you have in the question. Find P. You know, it's kind of hard. You just have that height. You have to find the pressure exerted. But that's all you need actually for finding pressure. Now the pressure P, from the last equation we derived, we know that P is equal to H rho G, right? P is equal to H rho G. Now what is H? H, you know, it is 10. What is rho? I had told you that this is water, right? This is H2O. Now what is the density of H2O? That is something you need to know. The density of H2O, write it down. Density of water is equal to 1000 kilogram per meter cube. That's what the density of water is, and it is quite important, because all the problems related to water, this is used. And in most of the problems, the problem is that you won't actually get the density of water in the question. Something you need to know. So pressure is equal to H rho G. So we'll start substituting. What is H? H is equal to 10. What is density of water? 1000. Now one thing you need to note is that when you calculate the pressure, it's not actually the density of the wood you have to calculate, it's the density of water, because that is the thing which exerts this pressure. So you should actually consider the density of water, or the thing which is exerting this pressure. Now back to our equation, 10 into 1000 into G. Now what is G? Gravitational constant, 9.8 meter per second square. Now what do you get from here? 98000. Now what is the unit? Is it atmospheric pressure? No, it's not. It's Pascal, since Pascal is the SI unit. So now we have done a problem. Now I hope you have understood what this is. So see you in the next video. In the next video we'll be dealing with atmospheric pressure and the principle of a barometer, and we'll be considering other fluids like mercury. Okay, thank you. See you in the next video.